Welcome back for another deep dive. This time, we're going way back to 1950
Oh, wow.
to explore
Uh,
Alan Turing's paper, Computing Machinery and Intelligence.
Wow, that's a classic.
Yeah, and our listeners are pretty tech savvy, right? They probably know a lot about AI already, especially deep learning, all this stuff that's happening now.
Right, right.
But imagine going back to AI before, well, almost everything. Before neural networks, before
Before the internet.
before the internet even.
It's amazing to think about.
It really is. And that's where this paper takes us.
It's really a foundational paper, I mean, even back then, Turing was already wrestling with that big question.
Yeah.
Can machines think? Really think?
And this wasn't just some thought experiment, right? He had a really clever way to, test this.
Oh, absolutely. The imitation game, he called it.
Right, the imitation game.
So picture this. A man, a woman, and an interrogator, they're all in separate rooms.
Okay.
And they can only communicate by typing messages back and forth.
Like a really old school chat room.
Exactly.
Okay.
And the interrogator has to figure out who's the man and who's the woman just by asking them questions.
That's tricky. I mean, how do you even...
Well, that's where Turing's genius comes in.
Okay.
He said, what if we replace the man with a machine?
Whoa.
Can the interrogator still tell the difference?
So basically, she predicted chatbots way back then.
In a way, yeah. He was thinking about how a machine could communicate and potentially deceive a human into thinking it was also human.
That's mind-blowing.
It really is. And he even gave examples of the kinds of questions the interrogator might ask, like asking the participants to write a sonnet or solve math problems or play chess.
Oh, wow. So he was thinking about, different kinds of intelligence, not just...
Not just factual knowledge, right?
Right.
But creativity, problem solving.
It's all there in the paper, actually. There's a figure 1, that lists out some sample questions.
Oh, that's right.
I'm looking at it now.
Fascinating stuff.
Now, if you were the machine in this game, how would you try to convince the interrogator that you were human?
That's a tough one.
What would your strategy be?
Well, I guess I'd try to maybe mimic the way humans write. Use slang, make some spelling mistakes, that kind of thing.
Oh, interesting. So kind of play into the stereotypes of how we think machines would communicate.
Right, because back then, people probably wouldn't expect a machine to be perfect, grammatically speaking.
That's a good point.
No.
And it makes you realize how much our perception of AI has changed over the years.
Absolutely. Turing was working with a completely different set of assumptions and limitations.
Yeah, computers back then were nowhere near as powerful as they are today.
Oh, yeah. Turing himself described the digital computers of his time as being a human with a book of rules, a stack of paper, and a desk calculator.
Really? That's it?
Pretty much.
I mean, can you imagine trying to do AI with just that?
It's remarkable what he was able to envision with such limited technology.
Yeah. He even laid out the basic structure of a digital computer in the paper, right?
Yeah,
His
right.
store, the executive unit, and the control.
Which in modern terms we'd call memory, processor, and program flow.
Exactly. It's all right there in figure 2.
And what's really striking is that even with those limitations, he grasped some incredibly profound concepts about computing. For example, the idea of a universal machine.
Oh, right. The universal machine.
Which is basically the foundation of how we understand computers today.
So he was saying that any computer, given enough time and memory,
can simulate any other computer.
Exactly. So today we have a single architecture, by 86 or ARM, that can run all sorts of different software.
Precisely. Turing saw that potential even back then.
Incredible. And he connected this idea of the universal machine back to the imitation game, right?
He did. He asked if a computer can simulate any other machine, could it theoretically simulate
the human mind?
Exactly.
And did he think it was possible?
Well, he believed that machines would eventually be able to play the imitation game convincingly. In fact, he even predicted that they would be able to do it by the end of the 20th century.
Wow. That's a pretty bold prediction.
It was. And of course, it sparked a lot of debate and controversy.
Oh, I bet. I mean, people must have had all sorts of objections to the idea of machines thinking.
They did. Some were based on religious beliefs, arguing that machines couldn't think because they didn't have souls.
Oh, wow.
But Turing actually addressed this.
He did?
Yeah, he pointed out that if God could create souls, maybe he could also bestow them upon machines.
Okay, that's a pretty interesting counter-argument.
It is. But there were other objections, too. Some people just found the whole idea too scary to even contemplate.
Like, they just didn't want to think about the possibility.
Exactly.
That's funny because even today, there's still a lot of fear and anxiety around AI.
It's true. But back then, there were also more technical objections.
No, like what?
Well, some were based on mathematical principles, like Gödel's incompleteness theorems.
Ugh,
Mm,
Gödel. Always a mind bender.
right. These theorems basically showed that there are inherent limitations to formal systems, like mathematics.
Okay.
And some people argued that these limitations would prevent machines from ever achieving true human-level reasoning.
So they were saying that machines could never be as smart as humans because of these fundamental mathematical limits.
Essentially, yes. But Turing argued that we can't definitively prove that those same limitations apply to the human intellect either.
That's a good point.
Mm,
I mean, humans make mistakes all the time, right? We have biases. We're not perfectly logical.
exactly.
So just because a machine might run into problems with certain logical paradoxes doesn't mean humans are inherently superior.
Precisely. But perhaps the most interesting counterargument was the argument from consciousness.
Oh, right. Consciousness. That's a tricky one.
It is. This argument basically says that we can never truly know if a machine is genuinely feeling something, even if it acts like it is.
Yeah, like, how do you prove that a machine is actually experiencing emotions and not just simulating them based on its programming?
Right. And Turing tackled this head on.
He did.
Yeah, he drew an analogy to a viva voce examination.
Oh, what?
A viva voce. It's like an oral exam where a student has to answer questions to demonstrate their understanding.
Oh, okay.
So Turing argued that if a machine could answer complex questions in a nuanced and insightful way, just like a student in an oral exam, it wouldn't be fair to dismiss its responses as mere artificial signaling.
So even if a machine can't literally feel emotions the way humans do, it could still demonstrate a deep understanding of those emotions.
Exactly. Turing's focus was on observable behavior, on whether a machine could convincingly mimic human thought and behavior.
So it's not about whether the machine is conscious, but whether it can act as if it is.
Precisely. He was more interested in what machines could actually do than in getting bogged down in philosophical debates about the nature of consciousness.
That's a very pragmatic approach.
It is, and it's a recurring theme in his work.
Which leads us to one of the most forward-thinking aspects of his paper, the concept of learning machines.
Ah, yes. This is where Turing really starts to lay the groundwork for the field of machine learning as we know it today.
Wait a minute, I think we need to take a quick break here.
Yeah.
We've covered a lot of ground already.
You're right, we have.
Let's pick this up in the next part of our deep dive, where we'll explore Turing's fascinating ideas about machines that can learn.
Sounds good to me. So where were we? Oh, right. Turing and his learning machines.
Right. Like, he knew that just programming in every single rule wouldn't cut it.
Exactly. You can't just, write a program for every little decision a person might make.
Way too complicated, right?
It's just not how intelligence really works, is it?
So he had this idea of a child machine.
Yeah. Like it starts simple and learns as it interacts, kind of a blank slate in a way.
Ah, so that's kind of like what neural networks today. They start basic and then all that data shapes them.
Right. Amazing how he was thinking about this stuff so long ago. He even used these really cool analogies.
Analogies. Okay, I'm intrigued.
Like the supercritical atomic pile.
Whoa, hold on. Atomic piles. What do those have to do with learning?
He saw a connection, right, with that chain reaction, that huge energy release. One little neutron sets it off,
Right.
It's like one idea in the machine could trigger a whole cascade of new thoughts, that explosion of knowledge.
Ah, so learning builds on itself, right? Like a snowball effect.
Exactly. He also talked about peeling back layers of an onion.
Okay, I like that one.
Yeah.
But it does make you wonder, though, like, is the mind really just layers, mechanical all the way down?
Right. Big questions. Even now, no easy answers there. But if for Turing, the point was you can build intelligence by kind of mimicking how kids learn.
Makes sense. But I guess teaching a machine isn't exactly like teaching a human kid, right?
Well, no. I mean, machines don't have bodies, don't experience the world the same way we do. So he talks about how just using rewards, like, giving points or something,
Doesn't really cut it.
wouldn't be enough. Like, imagine trying to learn a language by getting shocked every time you make a mistake.
Ouch. No thanks.
Right. So he's saying machines need something more. They need to learn from, symbols, logic.
More like how humans do it.
Yeah.
Right.
And he even talks about adding some randomness into the mix.
Randomness. Why would you do that?
So the machine can explore more, try different things. Instead of just testing every single option in order, which would take forever, they can jump around a bit and maybe find something cool faster.
So kind of like adding a little bit of creativity to the process.
Yeah, exactly. And, we still use that idea today, like in those genetic algorithms.
Wow, so he was really ahead of his time. But hold on, how do you even know if a machine is really learning, not just pretending?
Good question. Turing says you got to look at what it does, how it solves problems. And communication is key too, even if the machine doesn't have senses like ours. He used Helen Keller as an example, right?
Oh, wow, yeah.
Right.
Learned so much without sight or hearing. So learning isn't just about the body. It's about, I don't know, exchanging information.
Yeah, building understanding. And he makes this point that even the people who build these learning machines, they won't know everything going on inside. Like, you see the behavior, but
The machine's mind is its own thing. Kind of spooky, huh?
a little bit. Like, we might set it on this path of learning, but we don't completely control it.
So, big question, did Turing think we could really build machines that think?
Well, he didn't give a definitive answer, but he shifted the whole conversation. It's not about philosophy anymore. It's about what machines can actually do.
And how to build them.
Right.
So, what did he think that would take, practically speaking?
Well, that's where things get really interesting. He actually got into some specifics. He actually had some numbers in mind, like how much storage these machines would need.
Oh, really? So he was thinking practically about it.
Yeah, he figured about 10 to the ninth power binary digits.
10 to the ninth. Whoa, okay, I'm no math whiz, but that sounds like a lot.
It is. Imagine the whole Encyclopedia Britannica, like the 11th edition, all that information. That's roughly the storage he thought a thinking machine would need.
So, like, a lot of information. Makes sense.
Yeah.
But storage is one thing. What about the actual, programming? How do you build the brains?
Well, he gave a kind of wild estimate for that, too.
Oh, no, let me guess. It involved, like, a room full of monkeys typing Shakespeare.
Not quite. He said, picture 60 people working nonstop for 50 years. That's how much effort he thought it might take to program a machine smart enough to pass the imitation game.
60 people.
Yeah.
For 50 years. Okay, so even he knew this was a huge EO task.
Right. And while he didn't rule out, just brute forcing the programming, he also saw the beauty of the learning approach.
Makes sense. Like, instead of trying to hard code everything, you let the machine figure some stuff out on its own.
Exactly. Trying to predict every possible situation, every decision. It's just not practical, is it?
Nope, not at all. Plus, there's got to be some room for surprise, right? Like, that's where the cool stuff happens.
Absolutely. And Turing knew that embracing a bit of unpredictability, letting machines explore and make mistakes, that's a powerful idea.
And that's kind of what we do with AI now, isn't it? Give it
Ugh.
tons of data and let it find patterns we might miss.
Right. Turing was on to something there. And, he didn't shy away from the big questions either, like, what if these machines get smarter than us in some ways?
That must have ruffled some feathers back then.
Probably. But he wasn't afraid to go there. He wondered, where should we even start with this? Chess, language. Those are still hot topics in AI today.
It's amazing, isn't it? So many of these fundamental AI questions, Turing was already wrestling with them.
He laid the groundwork, really, provided a whole framework for thinking about AI. So next time you see some amazing new AI doing its thing, remember, it's building on those ideas Turing had.
Right.
Way back when.
It's true. We owe a lot to those early pioneers. Well, that about wraps up our deep dive into computing machinery and intelligence. Turing's paper is still so relevant today, It makes us think about what intelligence really is, about the limits of what we can build, and how our relationship with machines might evolve. If you're as fascinated by this as we are, we've got links to the paper itself and some other resources in the show notes. Thanks for joining us.